Okay, so let's go tackle this one. So putting this into a matrix, I can see I'm going to have 1, negative 3, 2, 1, 0, 2, 6, 8, 0, negative 2, negative 6, negative 9. All right, so I see that I've got a 1 here and zeros below, so that's all good. I see that these are exactly the same, so I'm going to suggest that we just take and add row 2 and row 3 together. So carrying along the first row, writing down the second row, and adding these together. So I get 0, 0, 0, and this last entry will be negative 1. Right now, I can see there is not a common point of interest, a common intersection point. How come? What do I see? Intersection. I see that this last row right here, it says that 0 equals negative 1. This tells me that the system is inconsistent. So there is no common point of intersection. All right, so here we are with H's and K's. So I know I can't just go solving it right away. I need to do row operations to get a 0 here. So I'm going to take row 1, multiply it by negative 3, and add it to row 2. So the first row stays the same. This turns into a 0 by multiplying by negative 3, negative 3h plus 6. Multiply by negative 3, that'll give me a negative 12, plus an 8, that gives me a negative 4. All right, so what does h have to be? Right, this is an augmented system, so this is like where the equal signs are. This is the x1 column, this is the x2 column, and this is the equal the numbers, right? So what does h have to be so that this is consistent? So if I've got this here, this number times x, so this would be the number x2 equaling negative 4. In order for this to be consistent, this has to not be 0. Must not be 0. If it was 0, that would give me 0 equaling negative 4, and that would be inconsistent. So I need to find out and solve for h, so you can see that you'll get h is equal to 2. So all the values of h that make this consistent are all real numbers except h equal 2. All right, so let's tackle this one a little bit different. I want to find the values of h that makes it a unique solution and the values of h that makes it infinitely many solutions. So I have to start off with row operations first. So I'm going to say let's multiply row 1 by negative 3 and add it to row 2. So row 1 stays the same. So negative 3 and add is 0. Negative 3 and add, that gives me h minus 12. Multiply by negative 3, that gives me a 6, minus a 6, that gives me a 0. All right, so to answer question for the part A, when is this a unique solution? Well, this here would say h minus 12 times x2 equals 0. So this will be unique as long as this h minus 12 does not equal 0. So when h does not equal 12, that's when I'm going to have all on one line and infinitely many solutions. Shoot. So when will this equation have infinitely many solutions? That will be when h minus 12 is equal to 0, because that will give me the last line of 0 equals 0, which is true, but that would mean that both of the equations of lines turned out to be one equation, so they were lines on top of each other. So when h equal 12, that's when there's infinitely many solutions. When it doesn't equal 12, that's when there's a unique solution. All right, one more and we'll finish it off. So this one has h's and k's in it. So here's 2, negative 1h, negative 6, 3, and k. All right, I'm not going to worry about making that a 1. I'm just going to say multiply row 1 by 3 and add it to row 2. So keep this one the same. So multiply by 3 and add, that gives me 0. Multiply by 3 and add, that gives me 0. Multiply by 3, so 3h plus a k. All right, so when will this be consistent? Well, this last row here says 0x1 plus 0x2 is equal to 3h plus k. In order for this to be consistent, this gets to be 0 is equal to 3h plus k, so that must mean that negative 3h is equal to k, or k is equal to negative 3h, but that must be true so that I don't get a false statement.